Hello everyone, today we're going to see a general way of approaching 1D dynamic programming questions. So the basic framework is going to be we are running through a 1D array and we try to go from position 0 to position n-1 while satisfying some conditions. In the forward way, we're going to be answering the question, is there a way I can get from index I to index n-1? And in this way, we're going to be using suffixes of any given position I to get the information that we would like. A boundary condition to consider in this case is that we can always go from position n-1 to position n-1. Essentially, this means we do nothing. So, in the forward way, if we are at some index I, then we're going to be wondering, is there an index j, which is between I and n-1, that I can get to? And we're going to be then asking the question, from that index j, is it possible to go to index n-1? If this is true, then this is also going to be true. So you're going to get that absolutely you can go from index I to n-1. So in this way, the recursion formula is a little bit abstract here. So essentially, if you are trying to answer that question at some index I, then you're going to have some abstract operator. This can be, in general, it can be max, min, or, and depends on the problem that you're tackling, but let's just keep it very abstract here. So we're going to say some abstract operator that is going to be called upon the suffixes of I which satisfy some transition condition. Essentially, you're going to be calling the function at this suffix only if you can draw this arrow here. And for some indices j, you're not going to be able to draw this arrow because it doesn't abide by some condition that you have on your problem. Which conclude the forward way. Now, the backward way is thinking a little bit differently. So essentially, we're going to be answering the question, can we go from index 0 to index I? And in mind, what we're going to be asking at the end of the problem is, can we go from index 0 to index n-1? And for each position I, we're going to be using the prefixes, the information at the prefixes of index I to propagate the information. So essentially, if we are at index I, we're going to be asking the question, is there some index j that I can get to from position 0, which then allows me also to go to position I. If you find such index, then the information is going to go from here to here. And you can then move to index I plus 1 and do the same thing. So here the recursion formula is a little bit abstract again, but essentially it bears some similarity with one we have on the left. In this way, it's going to be nevertheless easier because we know that we're going to be calling the prefixes, and those prefixes need to satisfy some transition condition with I. So essentially, you can solve any problem by either thinking forward or backward. The only differences that you're going to see in practice, in some example, is that thinking forward is very easy, but the recursion formula is quite complicated because here you are calling the suffixes, and in this way you're going to have some extra information that you need to keep in mind if you'd like to solve the problem in the forward way. But in the backward way it's much easier because you can actually use some tabulation. Essentially, if you know the answer for index 0, then you're able to know the answer for index 1, and then to index 2, and so on. And it's very easy this way because you see right away that the time complexity can be something like quadratic or linear. It depends on the problem that you have. So this concludes this introduction to solving 1D dynamic programming questions. We're going to see some example in the next videos, and I hope that it's going to make this first introduction clearer as we see more example. So you're going to be able to come back to this first video and see how this abstract way of approaching problem is applicable to many